So Kurt Hollowell, he is a rapid prototyper and interaction designer and just general kind of multi-hyphenate at Magic Leap. He's built over 100 mixed reality prototypes using gaze, gesture, voice, controllers. He's working really on like some of the most cutting edge technology for designing these, for interaction design available right now. And he's currently designing inputs and interactions for our next generation headset. Before coming to Magic Leap, Kurt worked at Sandia National Laboratories on mixed reality apps. And he also founded an indie game studio called Dog Eat Dog Games, where he released several game titles. And he's released a lot of tools also to the developer community on the Unity Asset Store. So I work with Kurt. I've worked with him a lot in the last couple of weeks, especially, and I'm always blown away at his innovation, his great attitude, and just how he's really always kind of blazing a trail in this field. So I'm super, super excited that he's going to share some knowledge with us.
A great introduction and great talk, Savannah. That was really nice. So yeah, hi everyone. My name is Kurt Hollowell, and today I'm going to be talking about designing interactions for spatial computing, mixed reality. So just a little bit about me. I'm from Albuquerque, New Mexico. If anyone has seen Breaking Bad, that's kind of my hometown. Really beautiful desert landscape with mountains in the background, and grew up there and really started my gaming career at Albuquerque Game Developers Guild. I just wanted to have a quick shout out to them. It was a local community that would meet up every week. People would show off the games and projects that they were working on and get feedback on it. And that's really what helped me kind of get started in the gaming industry. And right out of college, I started in a game studio. Just a little bit about me. When I was getting my campus tour for university at UNM, I saw that there was a class making video games. And before that point, I didn't really know what to do, but what I was going to do with my career. But as soon as I saw that class, it kind of clicked in my head instantly that, oh yeah, I'm going to make video games. And I had a lot of fun doing that. So yeah, I started a game studio and I released a handful of tools on the Unity Asset Store and made lots of games with spaceships and blowing stuff up, and also a lot of music-based games. I really like the games where it's reactive based on the audio. So I've made a handful of tools around that and experiences around that. So I've been at Magic Leap for 2 years, and now I am an interaction designer and rapid prototyper. So it's basically up to me to decide, how does the user perform a task and what feedback do we show? And I really have an interest in gesture interactions, especially. So a lot of my demos are related to that. But so my job at Magic Leap is really to think about the human-computer relationship. And I just want to have a quick shout out to this great book by Steve Swink, where he talks about game feel. And it's one quote from the book is that game feel is about maximizing the output of a player's inputs. So the user performs a task, and then as an interaction designer or a game designer, it's up to us to come up with the world and how does the content respond. And it's really about this relationship between the human and the computer. The user has, some perceptual field. They have an understanding of the environment, and then they might have an intent to perform an action, intent to interact. And to interact, they use some sort of input, like we're all familiar with, game controllers or a mouse and keyboard. They have some way to do something. And then, the system, the game world responds. You have audio and haptics and the way maybe the character moves or the game environment responds, and then the user interprets that response and performs another action. So that's really kind of my job in mixed reality, is to think about this relationship. How can we empower users to do the things they want to do quickly and efficiently, but also make it look, feel, and sound good? So in mixed reality, we have some new ways to interact with our digital content. As Savannah mentioned, we have head pose, which is basically the position and orientation of user's head in 3D space. We also have gaze, so where the user is looking, and it's not just only the orientation of their head, but we can actually use eye tracking to tell a specific point in space where the user is looking, and think about how we can have content respond to that. We also have voice interactions. These days, I think we're all pretty familiar with, Google and Siri and Alexa and all the different ways we can use our voice to ask intelligent questions. But I'll talk a little bit today about how we can use other things like gaze, head pose, and gestures to combine with voice to kind of step those interactions up a little bit. We also have our hands and tools like a remote control. In VR, we're really familiar with using these new types of controllers. And we're starting to get some, like with HoloLens, using gestures and leap motion hand tracking, if anyone's played with that. But and then finally, there's world understanding as well. So one thing that's kind of unique to augmented reality and mixed reality is not just about the player and the digital content, but it's also about the world around them. Like Savannah mentioned, it's about the location they're in, understanding where the walls in the room, where are playable surfaces, where are chairs, what are, just the more we can understand about the world around us, the more we can create compelling experiences in mixed reality. So I want to start my talk today talking about kind of the thing we're all most familiar with, which is controllers. So I think when you're designing mixed reality or really virtual reality experiences too with controllers, there's a few metaphors that come to mind, at least for me. And one metaphor is the controller as a remote. So basically using it as, a clicker, being able to just point and click on things. It's fairly simple, but it works well and users instantly know what to do. I think another metaphor to think of with controllers is the controller as a tool. In mixed reality, we can kind of change, add, in this case, some tweezers to the end of a controller, or a shovel, or scissors, or a hammer, or basically anything that you might find in like a garage or a workshop. You can transform the controller in your hand into something else that might make it either more precise or more productive, or design something that allows the controller to be very specific for a given task. And finally, I think we can think of controllers as physical real-world objects, like in Dr. Gordport's Invaders, maybe a gun or a sword. It's something we've seen a lot in VR. In augmented reality, it's surprising how just a digital overlay on top of the controller can really make it feel like you're holding that gun in your hand, or you're holding that sword or hammer or whatever the object is in your hand. So those are just, 3 different ways you can think about the controller when you're designing mixed reality or virtual reality experiences. So the next input I want to talk about is head pose. Like Savannah said earlier, it's really good for attention, and it's, head pose is just where is the headset and what's its orientation, position and orientation. So when I think about head pose, a lot of different things come to mind. As Savannah mentioned, we can think about attention. What is the general direction the user is looking, and how can the content respond? You might have an AI character that waves to you as you look at it, or meets your eye gaze. And we can also use head pose for targeting. HoloLens 1 did this really well, where they had basically like a little cursor, and as the user moved their head, the cursor would follow, and they were able to use that to interact with UI elements or content in distance by just looking at it and performing a light gesture with your hand. But as we think about user attention, one interesting concept is to think about attention over time. So not only where is the user looking now, but where were they looking and where are they about to look? So the best example I can think of to talk about this mechanic is maybe back in Dr. Gordport's that game where you're shooting robots. Maybe there's a few different characters in the world around you. You can look at one robot and start to aim at them, and then line up your shot, but immediately start looking towards the next target. And by understanding where the user was working, we can provide an aim assist towards that shot, even if the user isn't looking there anymore. So and so that's an example of attention in the past. We can also think about an intent to interact and attention in the future. So as a user begins to move their head towards a piece of content, you can have that content respond even before they've fully moved their gaze towards it. Another thing we can think about with head pose is gait and motion. So understanding when the user is moving around the world or when they're stationary, you could imagine like a web browser. Let's take YouTube for example. When you're watching a video in mixed reality, you might want to, let's say you're cooking in your kitchen, you might want that video to be stationary in the world around you, but then maybe you have to walk to the other room. Well, by looking at head pose and understanding when the user is moving versus when they're stationary, we could have that content follow them naturally throughout the world. And then as soon as they settle in a new location, the content could maybe persist in the world again. Another thing we can use head pose for is basically proximity to content and sizing of content. When designing UI and interfaces in mixed reality, we have all the same problems of layout and sizing and shape and look and feel of content, but there's also its kind of position in space. And how do we create interfaces that work well up close, but also work at a distance? And one simple way to do this is by having basically like a screen space size that stays the same. So you could imagine basically scaling content as it gets further away from the user to have it appear the same screen space size to the user. So that way they still have the same, hitboxes and affordances for regardless of their distance to the content, they can still perform the tasks that they want. Another interesting thing we can use head pose for is head gestures. You can nod yes or no to accept or dismiss dialogues, or depending on what your culture is, there's a variety of different things people actually do with their heads, maybe to indicate that they're listening, or a variety of different things. We can also actually use head pose for breath detection. Combining it with microphone input, we can tell when the user is in a relaxed state, when they're focused, but also we kind of tend to nod our heads up and down, especially if we're doing some sort of meditation exercise. So if you're building any kind of biometric-based app, you could use, head detection for understanding when they're moving, and also maybe their breath. And then finally, I want to talk about body pose, which, head pose is position and orientation of the head, but we notice like our shoulders and our waist sit beneath our head and kind of react at a little bit of a slower rate. You might, if you're at a workstation, your chest and your shoulders might stay relatively in the same place versus your head might be able to, gaze left and right. So same thing with laying out, UI interfaces and mixed reality, just trying to understand where the user's body is at and laying content out relative to their body versus having like a tether system that follows their head around. So one interesting thing that we can do with head pose is to encourage movement. This is a small developer sample that one of my teams created for mixed reality. And one of the interesting things in mixed reality is we can have like a button that a user can press. In Dr. Gordbort's, there's an example of this. But often when someone's kind of new to the medium, if you say, oh, go push the button, we're so used to kind of sitting in our chairs, sitting at our computers, that some people need a little bit of prompting to actually to move and say, no, you actually walk up to the button and press it. So just doing something in your experiences to encourage the user to walk around and not just sit still and interact, but to get them moving around. In this case, you can throw boulders at their head. Like I was mentioning before, another thing we can think of with AI design is proximity of the user to the content. So in this case, you see our little golem looks pretty fierce and angry when the user's away. He might be willing to attack. And then as you get close, he kind of cowers in fear. And then once you get really close, he runs away and hides. So this is just a small example of how your digital AI can react to the presence of the user. And this, like Savannah was mentioning with the shadows, kind of like tying digital content in the real world, just having AI respond to the user, I think really makes it feel a lot more present and lifelike. This is something that we found in VR too. Next, I want to talk about eye gaze a little bit. So with eye tracking, we can tell specifically where the user's eyes are looking in 3D space. So you can use this thing for targeting, like look at a button and say a word or do a light gesture to click it. We can also think about eye fixation. So it's kind of like with head pose, attention over time. There's the same thing with eye gaze. Our eyes naturally move really chaotically around the environment. They're often scanning the entire environment and looking back and forth. But if we look at that attention over time, we'll notice hot spots, and that signify an intent to interact. We can also do blink detection to tell when the users may be winking. Again, you could wink at an AI, and if you're trying to flirt with him or something. You can also do heartbeat and emotion. I'll talk a little bit more about this in a second. But this is a small demo one of my colleagues made about using eye gaze with a simple attention system. You can see the color of each cube kind of ramps up and down as it responds to the user's gaze. In this case, that kind of blue cursor that's moving around the environment. So the important thing here to learn is basically just that content should respond gaze over time. Like I said, users kind of scan the environment really quickly. So when we're designing interfaces, you might not want each of your elements to have like a strong hover state as the user's just gazing around. Rather, you want them to kind of sit and stare at it for a second before the content really responds. So, and showing that eye gaze cursor is actually quite distracting. So in this slide, I'm just demonstrating that really you want the content to respond to the user's gaze. You don't want to show that gaze cursor itself. This is a small example with two panoramas, again, that some of my colleagues have made, where just a simple animation that the content says, yes, I can tell that you're looking at me. So as I was mentioning before, you can also do heartbeat detection and emotional signifiers. Every time you have a pulse or your heart beats, your eyes actually flush with red and then white. So the cameras that we're using for eye tracking, we can actually also use for biometric data, similar to like a smartwatch where we can detect heartbeat. And also, we don't need the whole face to understand if someone's smiling or frowning. Just by looking at the small area around someone's eyes, you can tell when they're smiling or frowning. And especially when you combine it with everything else we just mentioned, like head pose, how often are they blinking, and what's their heart rate, we can get a little bit of insight into like what's the emotional state of the person wearing the device. So voice interactions, like I said before, I think we're all pretty familiar with these days with Siri and Alexa and Google. So I won't spend a ton of time on this, but I will just talk briefly about how voice is a little bit different for mixed reality or virtual reality. And the general speech flow when you're designing voice interfaces, it looks something like this. You have an initialization. So this might be something like just saying the word, hey Siri, or hey Alexa, or in our case, hey Lumen. So then the system starts listening. I think a lot of people are kind of worried that these voice systems are kind of always listening to their every word. But really, there's just a background program that's only listening for this initialization, this wake word. So it's just a dumb program. It's not saving any of the words you're saying or listening in on your private conversations. It's just this kind of background program that's waiting for that first moment of initialization where you say, hey Siri. Then the user can issue some set of commands that get bundled into an intent. So I think this has really evolved these days. These voice AIs are getting really good, where if you want to know the weather, you don't have to issue a very specific command. You might be able to say something like, oh, what's the weather outside today? Or is it sunny? Or maybe even like, should I bring my jacket outside? And the system can understand that and bundle it into what we call an intent, and then the system can respond with information about the weather. All these different intents, the system can respond in the same way. So after these phases 1 and 2, then you may have to go through some sort of disambiguation steps. So if the system doesn't understand specifically what you want to do, like if you just said open an app, then maybe you can go through some sort of disambiguation phase where the system responds and says, which app do you want to open? You could say Angry Birds, and then finally it completes the interaction. So with spatial computing and VR systems that have eye tracking, we can remove the need for this wake word because as we already understand what the user is about to do. And this is a very simple case where you might want to move something from one place to another. Well, if we can tell that the user is looking at a piece of content, then we can limit the amount of commands and contextualize them to the small set of actions that they can do with that piece of content. We can also remove the need for a wake-up word in these scenarios. So instead of saying, "Hey Siri, move this over there," or "Hey Siri, let's use that weather example," instead of using "What's the weather like?" Well, maybe we can just understand as the user's walking outside and have that weather information ready to the user without them even having to ask. So that's really all I wanted to say with voice, is basically just understanding the context of what the user's interacting with can help us significantly reduce, the set of commands we want to listen for and what they want to do. Next, I want to talk about something which is really my favorite input, which is hand tracking. I think it's really magical when I think we just use our hands so much in our everyday lives, and having digital content that can respond to that just feels a lot more immersive and real to me than kind of pointing at it with a control, like a game controller. There's one less thing in between the user and the digital content they want to interact with. So I want to briefly share an elicitation study that I did. Part of my job isn't just kind of building cool holograms to play with. It's also understanding what do people expect to do? How do they want to perform a task? So I ran a study last year with some colleagues where we presented users with a handful of different items of digital content, like some UI elements like buttons and toggles and sliders. We presented them with a keyboard and kind of this mock-up app where they could select different images or browse different pieces of content. And also some real world objects like briefcases and basketballs. And we kind of just asked them a handful of questions like, how would you, do the thing? In case of the keyboard, how would you expect to interact with this keyboard? Or how would you expect to press the button or move the slider? Really to just get an early understanding of, if we can understand and see an alignment on if a large number of users expect to do something a certain way, well, then we should probably design the input mechanics and feedback, to match that. So what we found is that, especially for these real world objects, that there was a really high alignment on the way people did something. So for something like the basketball, we'd ask them, how would you grab the ball and pass it to me? There's extremely high alignment where almost everyone just would grab it with both sides and do like a chest push. And that's because we already have an understanding of how to interact with these objects in the real world around us. So same thing with a briefcase example. We asked them like, how would you grab this object and move it around? And this one, because it has that physical affordance of a handle, almost everyone's like, well, yeah, I grab the handle, obviously, like that's how I grab briefcases. And this seems pretty, intuitive when you look at it in hindsight, but one thing I really got out of this is that like the shape and size and color of the object affects how users expect to interact with it. So, Savannah mentioned skeuomorphism, and I'm just going to bring it up too. And we found that if you're designing UI interfaces specifically for gesture and solely for gesture, then skeuomorphism seems like a really good way to go, because you'll have a very high agreement on the way users intend to interact with that thing. Now, I'll say, it's more learnable and intuitive, and like I said before, it kind of mimics the way we're used to interacting with these objects in the real world around us. So I'll say a small caveat to this is when we're designing UI interfaces for multiple inputs. So if we want to design something that doesn't work just for gesture, but it also works for control and voice and head pose and other things, then I think this kind of semi-skeuomorphic UI is the right way to go, where it may look like a pushable button that they can poke with their finger, but it also it's kind of this blend in between a physical object where the user can still recognize, oh yeah, that's a button and I can push it with my finger, but it doesn't go completely skeuomorphic towards the real world object like I'm showing in here. It's maybe something a little bit more in between the physical object and what we're used to seeing in like a digital, 2D interface. So as we're designing these different inputs and mechanics, I think a lot about how can we design tools that complement the input? How can the user perform the tasks in the best way? And I think a good analogy for this is touchscreen interactions. I don't know if y'all remember when touchscreens first came out, nobody really knew what to do with it. And I think it's the same with mouse and keyboard, and same thing with VR. Every time we get some new hardware, it kind of takes developers a while to figure out like, oh, how do we design experiences for this new way of interacting? So that's kind of where we're at with spatial computing right now. But yeah, I remember when touchscreens first came out, a lot of people kind of ported their games over to mobile and said, well, I don't really know how to design a game for touchscreens, so I'm just going to slap a controller on the screen. And while I think that's, in some cases, it can work if you keep it very simple, I think we can all agree that these other apps that really embrace the input at its core, like Fruit Ninja and Angry Birds, really shined because they embrace things that touchscreens are good at. Swipes, flicks, drags, taps, this kind of pinch and zoom scroll. These experiences and interactions were designed with the input mechanic in mind, and they leverage that to perform the task in like a much more natural way. So I think we're kind of at the same spot with gesture interactions, especially indirect. We're seeing high alignment, and when I say indirect, I mean content in the distance. I'm trying to figure out as a designer at Magic Leap how do users use their hands to interact with mixed reality when it's up close and when it's at a distance. And right now we're kind of seeing this trend where we're saying, well, let's kind of pretend the hand is a controller and we have all these UI interfaces that work well with kind of our remote controls. So let's slap a ray or a pointer on top of the hand and use that to interact with the world. And while that's good at certain things, it actually allows us to do precise targeting, and it's very simple in most of these use cases. You kind of point and pinch, so it's really easy for the user to basically do like a point and click interaction with this. However, in my opinion, I think we're losing all of the things that the hand is good at. When I think of gesture interactions that really make me smile, it's one that mimic kind of real world interactions. Like this Cat Explorer app on the Elite Motion is so awesome. And some of the other designs where UI elements are squishy and poke, users want to use their hands to grab, to pinch, to poke, to throw, to punch, to slap, all these different things that our hands are good at and we're used to. We want to reach out and touch things. So I think when we're designing gesture interactions in mixed reality, we should really embrace this way of thinking and empower users to use their hands like they want to. Also with gesture interactions, we need to provide multiple ways for users to perform the same task. In this case, this handle can be grabbed or it can be pushed. So I think this adds a little bit more physicality and realism to the UI interface and just allows users, we find with gestures that there might be a few different ways that people expect to do something. And I think in a lot of VR, we've realized that if a user expects to do something and the system doesn't respond in the right way, then it totally breaks that moment of immersion. So I think user testing is extremely important, and putting stuff in front of users and understanding, how are they trying to do the thing, and then building the interface to work with their initial expectations. I'll also say with hand tracking that hand representation is an interesting thing. It's basically, my point here is that the shape that we give the user's hands will inform how they expect to perform the task. A small example is that if the only digital UI we provide on top of users' hands is maybe like a small point on their fingertip, well, then they'll want to use their fingertips to interact with everything. If we turn their hands into boxing gloves, well, then they'll think that they have to punch everything in the world around them. So as you're designing your experience, just think about kind of the metaphor that you want to use around the hands. Do you want something more realistic, or do you want to encourage some other type of way for users to use their hands, turn it to something else? Another interesting thing with gesture interactions is that distance feedback is super important. Savannah mentioned shadows that help us, tie digital content into the real world. And another thing that shadows do in the real world is help us with depth perception. As you reach your hand towards, to pick something up in the real world, there's actually a lot of subtle cues that come together that help you with depth perception. And in digital reality, we need a little, or in mixed reality, we need a little bit of assistance from feedback systems to help the user understand how close they are to the content. Otherwise, it can be a little hard to understand. So in this top left one, you can see I'm playing around with distance to real world surfaces. In the top right one, it's something as simple as clicking a button. You can see glow on the hand that responds as the user approaches the button to let them know how close they're getting. In the bottom left, it's something, basically like a drop shadow that shrinks as the user approaches. That's really effective. And in the bottom right, it's a pretty simple color change. What I like about that one is there's actually two different feedback loops there, one for the approach and another one for the dwell. So as the user approaches, there's this blue bar that goes up, and then once they begin intersecting with the button, there's another bar, a green, that has to fill up. They have to basically press the button for maybe half a second for the button to respond. And that's also important with gesture interactions, because you wouldn't want to, in this case with that hand UI in the bottom right, as the user clicks one button, they might drop their hand, or and you don't want them to accidentally click all the buttons on the way down. So having a little bit of extra filtering there and make sure that they really have to kind of hold it for a second before it gets pressed. Briefly, just a couple emerging patterns I'm seeing with hand tracking. One is this kind of palm towards your face for menu systems. There's another leap motion example that I like. The nice thing about using the palm towards your face is that it doesn't conflict with interacting with digital content. If the user intends to do something in the world, click a button or grab something, then the content in front of them, then the user reaches their palm. The palm faces the thing that they want to interact with. So by kind of reserving this palm towards the face for system menus, I think is a great thing. It's kind of a safe space, and it's really easy to perform and remember. One other comment I'll mention with this, I really love this example. However, we can also design systems that work with a single hand. In this case, the user has to use two hands, which is great. But in mixed reality, especially right now with with our high focus on productivity and stuff, a user might have something else in their other hands. They might be carrying something, or have a pen, or their phone in the other hand. So designing menu systems that work with a single hand, I'd say, if possible, are just the way to go. Another emerging pattern we're seeing is kind of this like cage, or at Magic Leap we tend to call them prisms, but basically just UI affordances around 3D objects that let you perform like move, scale, and resize interactions. And there's also bimanual interactions. I think the pinch to zoom has already kind of translated into the VR space with like the two-handed controller, like poke and spread and rotate. I think we'll see that in mixed reality as well, with hands and controllers. Any normal. So that's, I know it's been a lot. We've talked about gaze and controllers and gestures and voice. And I'll just talk briefly about how we can combine some of these things. Specifically gaze and gesture, I think is really powerful. We can start to think about the head, the eyes, and hands as an integrated system. As a user begins to, if you go to pick up a coffee cup or something on your table, well, you might look at it with your eyes and then turn your head, and then your shoulders might turn, and then you'll begin to lift your arm towards the thing you want to grab. And all of these things kind of converge into one line that signify like a strong intention to interact. And we can use that for filtering. We can filtering out accident in the user's intent, and also just making things very responsive and quick. Being able to look at a piece of content and issue a quick voice command or perform a light gesture in the air to just get things done very quickly can feel extremely powerful. So one of the last inputs that I haven't talked too much is about world understanding. So world understanding is just all about, how does a system understand the environment around us? And right now, there's a few things I'd like to talk about that we can do on Magic Leap devices and other augmented reality. And the first one is meshing. And that's really like this close fit approximation of the world around us. So the headset has IR sensors that it uses to bounce light off the environment and basically get the flight time from the headset to the environment and back to understand how far away that is. And then we can build, 3D model on top of that to basically get occlusion and collision. So occlusion is basically just, if something goes behind something else, then you don't see it anymore. So you can notice like the balls on the couch there, you can't see them when you're looking at the couch. And then also just collision. So being able to have digital content that interacts with the world around you, again, is another way to make it feel immersive and tie it into the real world. There's also a plane system, which is a bit more of like a rough approximation of the world around us. So finding flat surfaces in the world, it's a good way to like quickly approximate the bounds of your environment, or to find like playable surfaces, placing content on the walls or on horizontal surfaces. Here's a small example of a placement system where the user is kind of looking at the wall. The system says, oh, look, there's a wall there and there's a valid placement position, and then using just a light gesture to perform an interaction. So this is using world understanding to see where the planes are. The user is using their head to control where that little green and red cage shows up, and then a light gesture perform an action at a distance. So this is just a small example of how we take these different pieces and bring them together. We can get things done quickly and efficiently. One interesting thing about, when we talk about the environment that I don't think everyone necessarily thinks about is kind of the space in between. If you look in the room, you might think about putting things on the walls or the tables or floors, but we also have to think about, kind of the empty space and how do we want to use that. Another Leap Motion example I really like here provides this grid system for placement of objects. You might not want to show this all the time, but I think it's a really interesting way to basically provide like some digital affordances that help users perform a task, and in this case, placing content in a specific location. These grid systems are also good for gaze vergence in the empty space. Like our eyes are really good at focusing on something. And if you're using eye gaze to place something, if you want to place it in the middle of the room, well, we can provide these types of grids to basically give them something to look at. So the user could look at one of these dots and then perform a light gesture to like move content to one of those locations in the empty space. So it's about giving the user something to focus on in that case. With world understanding, we can also identify objects in the world around us, like chairs, for example. One of my favorite mixed reality moments was on HoloLens 1 when I played this game Fragments, and I think they do an astounding job of understanding the world environment and having the AI respond. I just remember some scenes where in this game, you're like a detective and going through memories of other people, and they could just transform the room. You start looking down and, wooden floors start popping up and the walls start changing and windows appear. So the more we can understand about the environment, we can really transform that environment. And then another really powerful moment in this was having an AI characters that would go and sit on your couch, which was just mind-blowing and really, really made them feel immersive and just a part of the world around you. So the more we can understand about the space around us, the more we can have our digital content react to that space and use it. Good benefits. When we talk about world understanding and spatial computing, another interesting thing to keep in mind is basically what I'm calling here is interaction fields. And this is basically like little bubbles around the user and where they might perform different types of tasks. And I think a good metaphor for this is sitting at your desk, where if you're sitting at a desk, you might have this kind of like task space, which is all the things on the desk in front of you, your mouse, your keyboard, your pen, everything that's in reaching distance. And then there's kind of this workspace, which is maybe you have to lean over to one side to open a file in a file cabinet, or then there's kind of the extended workspace where you might have to actually get up and move to interact with it. And then there's beyond that, there's content in the distance. And it's just important to think about the size and shape of objects and their motion in these different kind of zones relative to the user to help you when you're designing your mixed reality experiences. Finally, another thing I think is a great way to teach users how to interact in mixed reality and virtual reality is kind of this monkey see, monkey do. This is another Leap Motion example where we have kind of a simple avatar in the distance performing a task, and then the user can basically just mimic that. I think it's a super powerful way for teaching in mixed reality and VR. So we're nearing the end of my talk here. Just a few quick takeaways. So when we're designing for controller-based experiences, we can think of our controller as a remote. We can think of it as a tool like scissors or tweezers. We can think of it as a physical object like a gun or a sword or a hammer. When we're thinking about head pose and input, we can think about content reacting to the position of the user, scaling based on distance, or reacting to their gaze. Also thinking about their gaze over time. When we're designing gesture interfaces, we should think about natural and physical interactions that mimic the way we use our hands in the real world so users know exactly what they're supposed to do. When we're designing voice interactions, in mixed reality, we can use gaze to determine context and kind of remove that need for the hey Siri, the hey Alexa, the wake up word. If we can understand where the user's looking, then we already know, what they're about to do and can limit the amount of voice commands we're listening to. The next line, gaze, an indicator for attention and intent to interact, as I said before. If you can combine gaze with a small, tap of the hand or a click of a trigger, then you can get things done really quickly. It feels really powerful. Finally, we can also understand the world around us for things like occlusion and collision. How do we place content in the world around us? How do AI navigate the world around us? An interesting point there that I forgot to mention before with occlusion, being able to see digital content versus the real world. I think that's something we'll still play with more in the future. One of the stumbling blocks that we run into in the past is that sometimes users want digital content to respect the environment, and sometimes they don't. Actually, sometimes, if your menu, there's frustrating moments where your menu is stuck behind a wall and you can't see it. You just want to, click a button or get a job done, but it's, it's stuck behind a wall or something. So sometimes for maybe system actions and different menus, you may not want to respect the environment around you. You might just want to, have the digital content shine through. Finally, a last piece of my advice for anyone interested in game development or mixed reality and VR is basically just get in touch with your local game development community. That was really helpful to me to, like I said, start my career. And they also kind of provide these like weekly motivation moments, these talks and events that we all attend, like GDC and the Filmgate and MUTEC events, I think are great. They're kind of inspirational moments where we see what other people are doing in the community, and it inspires us to kind of to make something or learn something and do something. So I would say either research what game dev meetups are in your local area. If you're in Florida, there's a great one, the Florida Game Developers Association. And if there isn't a game community in your area, then maybe you should start one. It's a great way to meet people, and I certainly wouldn't have my job at Magic Leap if I never joined a game dev community. And that's it for my talk today. Thanks everyone for the time. I really appreciate you being here to explore mixed reality with us. I'll hand it off back to the hosts.